Welcome to the channel. Thanks for joining us, your one-stop destination for everything AI. If this is your first time, please consider subscribing and ringing that all notification bell. A revolutionary breakthrough in aviation technology is unfolding at KAIST. Researchers there have developed an artificial intelligence humanoid robot named PIBOT that can pilot an aircraft entirely on its own. Through dexterous robotic hands and arms, PIBOT can manipulate the yoke, throttle, flaps and other controls in the cockpit to safely take off, cruise, and land transport jets. This represents a paradigm shift in autonomous flight, enabled by exponential advances in sensor technologies, computing power, and AI neural networks. PIBOT leverages large language models to comprehend flight manuals and demonstrate skilled flying proficiency. Developers emphasize it makes dynamic real-time decisions, unlike scripted autopilots. PIBOT's capabilities could significantly expand airline capacity and address pilot shortages. The military also sees major applications for robotic pilots to enable pilotless cargo and combat missions. But regulators face steep challenges certifying safety standards for autonomous flights. Thorny debates loom around liability, job impacts, and gaining public trust. A team of engineers and AI researchers have achieved a major breakthrough in developing AI-powered humanoid robots that can fly airplanes. The humanoid robot pilot, named PIBOT, can perform all the functions required to operate a plane from takeoff to landing entirely on its own. Standing 5 feet 3 inches tall and weighing 143 pounds, PIBOT sits in the cockpit seat of an aircraft and dexterously manipulates the yoke, throttle, flaps, gear lever and other controls with its robotic hands and fingers. Through a network of onboard cameras, PIBOT monitors the instrument panel and out-the-window view, while integrating altitude, airspeed, engine performance and other data sources to make flying judgments. Unlike autopilot systems that follow predetermined scripts, PIBOT makes dynamic decisions in real time, reacting to changing situations, just as human pilots. The engineers emphasize that PIBOT is not just repeating fixed pre-programmed sequences of actions, but uses artificial intelligence to respond immediately and appropriately to any in-flight scenario. For example, if an engine fails or the aircraft encounters unexpected turbulence, PIBOT can quickly take manual control, troubleshoot issues and plot an emergency landing route if needed. The dexterous humanoid form allows PIBOT to seamlessly interact with cockpit controls designed for human hands, without modifications. PIBOT also leverages large language models like ChatGPT to absorb and comprehend complex documents like flight manuals, aeronautical charts and aircraft reference handbooks. This allows PIBOT to memorize vast amounts of expert flying knowledge that far exceeds human capabilities. For example, PIBOT can memorize the entire worldwide database of JetVision navigation charts and relevant details for every commercial airport. Human pilots cannot match this level of vast knowledge retention. The engineering team put PIBOT through rigorous testing in a commercial flight simulator over many months. In repeated trials, PIBOT demonstrated skilled proficiency in all aspects of flying transport category aircraft, through various weather conditions, system failures, and challenging situations. Test runs included executing prep procedures, taxiing, takeoffs, instrument approaches, landings, and all other normal and emergency maneuvers. Unlike human pilots, PIBOT consistently adheres to prescribed procedures with no deviations, shortcuts or omissions. With an emotionless machine personality, PIBOT performs optimally in stressful situations where humans may experience cognitive overload and tunnel vision. The engineering team believes robotic pilots like PIBOT can fly missions more safely than even the most seasoned human aviators. As one example, PIBOT can consult the aircraft's quick reference handbook and perfectly execute emergency checklists in seconds, far faster than humans can. In an engine fire, rapid depressurization or other crisis scenarios, PIBOT's quick reflexes and unimpaired troubleshooting abilities give it a strong advantage over human pilots. Looking ahead, the team envisions PIBOT revolutionizing not just aviation, but also ground vehicles. The dexterous humanoid form factor allows PIBOT to transfer its piloting skills to driving cars, trucks, buses, trains, heavy construction equipment, military tanks or vessels, with minimal additional training. Companies may find it more advantageous to hire robotic drivers that don't require salaries, benefits, or sleep. The ADD is eager to develop PIBOT and other autonomous piloting systems for applications in both civil aviation and military contexts. For civil aviation, AI robot pilots like PIBOT could significantly address the current pilot shortage causing flight cancellations worldwide. Airlines are facing challenges finding enough qualified pilots. As crews near mandatory retirement age, deploying robotic pilots on certain routes could expand capacity without the costs, training and recruiting challenges of hiring more human crews. In military contexts, PIBOT could enable unmanned cargo delivery missions, minimizing risk to human pilots. Fully autonomous fighter jets and remote piloting capabilities are also possibilities, removing onboard crews from harm. Militaries are highly motivated to reduce casualties by substituting robot forces for soldiers whenever feasible. The KAIST team next plans flight testing of PIBOT in a light aircraft, before expanding trials to larger fixed-wing planes and helicopters. They are targeting project completion by 2026. Longer term, the scientists envision improving PIBOT's bipedal locomotion system to enable the robot to walk onto the aircraft itself, load cargo, refuel, and conduct pre-flight inspections with computer vision and other sensors. While further development is still needed, PIBOT represents a paradigm shift in merging aviation and artificial intelligence. With sensor technologies and computing power improving exponentially, robotic pilots could perform increasing percentages of flights worldwide. However, regulators and the public must debate thorny issues around safety assurances, liability, job impacts, and public acceptance. Automation in the cockpit has steadily advanced from early autopilots to modern fly-by-wire flight control systems. But the leap to fully autonomous flights represents a profound turning point. Airlines and manufacturers are pressing ahead with testing, eager to slash labor costs and outcompete rivals. But pilot unions and skeptical consumers argue human oversight must remain firmly in command. As aviation progresses to new levels of autonomy, regulators face complex certification challenges. Establishing rigorous standards to validate safety will be crucial. While AI systems can excel in normal conditions, ensuring they respond properly in rare but dangerous situations poses deep technical hurdles. And even mature systems are vulnerable to sensor failures, power outages, software bugs, and hacking. Liability questions around fatal crashes can be very difficult to resolve. If an autopilot system is ever found responsible for accidents, class action lawsuits by victims' families could cripple manufacturers. The technical complexity of these automation systems makes it harder to establish clear-cut accountability. To gain public trust, the involved companies and regulators will need to be exceedingly transparent about reliability data and redundancy safeguards. The job impacts from displacing human pilots are another thorny concern. Pilot unions worry that automation threatens the livelihoods of over 600,000 aviation professionals worldwide. Lobbying groups will fiercely resist AI robotic pilots if they jeopardize members' interests and negotiating leverage. On the other hand, airlines will aggressively fight to lower labor costs, even at the expense of reducing jobs. There are no easy political solutions for balancing these competing interests. Surveys show the general public still has limited comfort with fully automated flights. Trust is easier to gain for pilotless cargo planes versus passenger jets. People are open to autonomy for mundane commuter hops, but prefer human oversight for long trips. Winning consumer confidence may require transitioning slowly and allowing humans to retain override authority. Innovators will need tactful marketing campaigns to earn public buy-in. As KAIST rapidly advances PIBOT's capabilities, stakeholders across the ecosystem are awakening to the disruptive potential of AI robot pilots becoming mainstream. Incumbents like Boeing and Airbus downplay near-term threats, while funding their own automated flight decks to hedge bets. Meanwhile, upstarts are rushing to stake out patents around key autonomous aircraft technologies before regulators solidify rules of the road. One way or another, aviation is embarking on a transformation to technologies enabling one pilot or even fully pilotless flights. But with so many open questions around safety assurances, job losses, liability, and customer readiness, the timing and pace of adoption remain highly uncertain. The coming decade promises fierce debates as society and industry grapple with aligning values, ethics, and pragmatism on rolling out autonomous flight. In summary, PIBOT epitomizes the ascendance of AI in aviation. Developers have achieved a breakthrough in creating autonomous humanoid robots capable of flying entire missions. But many open questions remain around certifying safety, assigning legal accountability, mitigating job losses, and winning consumer confidence. Powerful incumbent stakeholders like pilot unions and plane manufacturers will resist threats to their interests. But airlines and tech innovators are forging ahead, eager to capitalize on enormous potential cost savings. One way or another, increased automation of flights now seems inevitable, despite the pitfalls. But striking the right balance between pragmatism and ethics around deploying autonomous flight remains a profound challenge for society. Regulators, companies, and citizens worldwide will grapple to align new technologies with shared values. What do you think about these PIBOT and automatic robot pilots? Don't forget to click the notification bell, so you never miss out on the newest updates in the world of AI. We are highly interested in your feedback, and how we can improve, or bring additional topics of high interest. Remember, every like, comment, and share brings us closer together as a community. Until next time, stay curious, stay passionate, and most importantly, stay awesome. Thank you everyone, and we will see you in the next video. This is Make Money AI signing off.